This section talks about using the metric system, and specifically we're going to be focusing on how to use the density formula. And first we'll look at where some of the units come from when we are talking about density and volume and mass. So it says a cube measuring 1 centimeter on each side has a volume of 1 centimeter cubed. So a cube just like this, we'll assume these are all 1 centimeter in length, has a volume of 1 centimeter cubed. This is equivalent to 1 milliliter. So that's a metric unit, milliliter. A centimeter cube filled with water, so if I were to fill this cube with water, it would have a mass of 1 gram. So 1 gram, or gram, that's the unit we're going to use when we're talking about mass. Okay, next we're going to talk about density. So the density of a substance is its mass per unit of volume. So it's kind of like how much stuff is in the cube, like how much or how tightly packed is the mass. It's kind of what the density is. So the density of water is 1 gram per centimeter cubed. So when we're talking about density, the unit we're going to use is gram per centimeter cubed. This little line means grams per centimeter cubed. So if I were going to fill this with water, the density of water is 1 gram per centimeter cubed. So since that is the density of water, if a substance has density that's greater than 1 centimeter cubed, then this should say 1 gram per centimeter cubed. Sorry. So substances with densities greater than 1 gram per centimeter cubed sink in water because they're more compact. They're going to sink. So let's say some substance had a density of 2 grams per centimeter cubed. Then it would sink if you put it in water. Substances with densities less than 1 gram per centimeter cubed, again that should say gram per centimeter cubed, they would float in water. Okay, so if it's not as compact as water, if maybe something had a density of 0.5 grams per centimeter cubed, it would float in water. Okay, so what we're going to be focusing on most today is this formula here. So to find density, density is always equal to whatever the mass is divided by the volume. And the variables we're going to use for this formula are D equals M divided by V. So this is how density, mass, and volume are related with this equation. So let's say I wanted to think about apples. Okay, I knew that a given amount of apples had a mass of 23.5 grams, a volume of 25.1 centimeters cubed. And I want to figure out the density. So the density, well, I know the mass and I know the volume. And if I'm trying to find the density, all I have to do is divide the mass by the volume because of this formula here. So the density is going to be M divided by V, which in this case is 23.5 divided by 25.1. So if you take out your calculator, divide 23.5 by 25.1, you get about 0.9, we'll round it to about 0.94. So D is about 0.94. And remember, for density, we use the unit of grams per centimeter cubed. Okay, so there's your density. And then we're going to think about, would this float in water? Well, 0.94 is less than 1, so the density is less than that of water. So if substances with densities less than 1 gram per centimeter cubed would float. So this would be yes. All right, let's think about ice next. So this time I'm missing the mass. I know the volume and the density, but I don't know the mass. But what we're going to do is we're going to use the same formula. So I know the way that density, mass, and volume are related is with this formula here. So if I plug in what I know, well, I know that the volume is, so density is 0.919. The volume is 1.43. I don't know the mass, so I'm just going to leave that as m for now. Well, now this is just a one-step decimal equation. I need to get m by itself. Right now it's being divided by 1.43. So to undo that division, I'm going to multiply everything by 1.43. Those cancel out. And on the left side, I'll do 1.43 times 0.919. And I get 1.3-ish. I'll just put 1.3. So 1.3 is my mass. And then my units for mass are grams. So 1.3 grams. And I've got my mass. Would this float or sink in water? Well, that has to do with the density. So the density is less than 1. 0.919 is less than 1, which is the density of water. So yes, this would float. And we can already actually jump ahead for the diamonds. 3.5 grams per centimeter cubed. That's definitely bigger than 1. So anything bigger than 1 would sink. So is it going to float, yes or no? No, it would sink. Just jumped ahead for a minute. All right, solid soap. So let's say I have 15.269 grams of soap, and I know the volume is 17.8566 centimeters cubed, and I want to find the density. So I'm going to do this just like I solved for density with the apples. So density is just mass divided by volume, which in this case is 15.269 divided by 17.8566. Type that in on your calculator. 15.269 divided by 17.8566. Hit enter. And it's about 0.855. 0.855. And again, my units are grams per centimeter cubed. So this has a density less than 1, 0.855. So it's going to float in water. If it's less than 1, then it floats. Last one, diamonds. So I know the volume and the density. I want to solve for the mass. So I'm going to do a similar process that I did up here. So I know I start with this this formula, D equals M over V. A handy little trick I learned to help you memorize the density formula is it kind of looks like when you do the M over V, it kind of looks like a heart. You know, if you D equals M over V, kind of looks like a heart. So if that helps you remember the formula, there's a little trick. Okay. Anyways, let's solve for mass here. So I know the volume and I know the density, so I'm going to substitute those values. 3.5 is my density, so I'm going to substitute that for D. I don't know the mass, but I do know the volume is 0.5. I'm going to substitute that in for V. And then solve for M. So right now M is being divided by 0.5, so to undo that division, I multiply by 0.5 on both sides of my equation. So now I've got 3.5 times 0.5. 3.5 times 0.5. Give me 1.75 equals M. Don't forget your units. Grams are our units for mass.